Hi students, welcome to my lectures on thermodynamics. In today's lecture, we are going to discuss about one more example of finding enthalpy of reaction through heat of formation data. In the last class, we have discussed a similar example, but in today's example, what the difference you are going to notice is the stoichiometry of the reaction is not equal. That means not equal to 1. For example, consider this reaction. HCl plus oxygen react to form water and chlorine. If you observe the stoichiometry of the reaction, it is not 1 everywhere. Here 4 moles of HCl in the gas phase reacting with 1 mole of oxygen in the gas phase to form 2 moles of water in the gas phase plus 2 moles of chlorine in the gas phase. Okay. Now the stoichiometry is the different. While finding the heat of reaction through the heat of formation data, you have to consider these moles into picture. For example, let us take, because if you refer to the any books, you are going to find out the enthalpy of formation data for many compounds. For example, enthalpy of formation of HCl at 298 Kelvin at 1 bar. I told you this symbol representing the pressure is always 1 bar. Okay. So the heat of formation of HCl at this temperature is minus 92307 joule per mole of HCl. That means every 1 mole of HCl is forming, that means minus 92307 joules of heat you have to, it is getting released. Minus means it is an exothermic reaction. Okay. Similarly, the enthalpy of the formation of the oxygen, diatomic gases of same element is always 0. O2, N2, Cl2, these called diatomic gases of the same element. Okay. For those, then generally it exists in its standard state. It is existing at its natural state. So whichever the compound is existing in its natural state, the enthalpy of the formation is considered as a 0. That is why enthalpy of formation of oxygen at this temperature, at this pressure 1 bar is 0 joules per mole of oxygen. Similarly, the enthalpy of formation of water and enthalpy of the formation of the chlorine is given in the form of this table. And you have to consider in which phase it is existing. The reaction happening in the gas phase. That means enthalpy of the formation data of all the compounds you have to consider in the gas phases only. Okay. So assume that this is the data of all the compounds of formations in the gas phase only. Let us calculate the enthalpy of this particular reaction. As you know, enthalpy of the reaction is nothing but the enthalpy of the products minus enthalpy of the reactants. That is why enthalpy of the products, now you can see every enthalpy of water is multiplied by 2. Enthalpy of the chlorine is also multiplied by 2. That's why 2 times the enthalpy of the formation of water plus 2 times the enthalpy of the formation of the chlorine. So this is in the product side. In the reactant side, 4 moles of HCl and 1 mole of oxygen. That is why 4 moles of enthalpy of the formation of the HCl plus 1 mole of enthalpy of the formation of the oxygen. So I have already the data, enthalpy of the formation data available with me. Once you substitute the enthalpy of the formation data of all the compounds, you are going to get the enthalpy of this particular reaction is nothing but minus 114408 joules. That means minus indicating it's an exothermic reaction. That means heat will be evolved because of this reaction. So what is this enthalpy of the reaction? Joules per mole of HCl or per mole of water or per mole of chlorine. This is very important. Okay. This is the enthalpy of formation, enthalpy of the reaction. By reacting 4 moles of HCl and 1 mole of oxygen gives rise to 2 moles of water will be formed and 2 moles of chlorine will be formed. That means this particular enthalpy you have to divide in this, because if you're saying in terms of HCl, that means in terms of HCl, every 1 mole of HCl that is reacting, how many moles of energy is released? That means The enthalpy of the reaction minus 11,408 joules per mole of HCl, 4 mole of HCl. That means minus 28602 joule per mole of HCl. That means every 1 mole of HCl is getting reacted. That means minus 28602 joules of energy is released, or every 1 mole of oxygen. That means this much amount of energy is released, every 1 mole of oxygen is consumed in the reaction. That means minus 11,408 joule per mole of oxygen is reacting. In terms of product, minus 57204 joule per every mole of water it is getting formed. That is why we have to divide it by 2 mole of water. That is why because of this reaction, every water molecule, 1 mole of water molecule is getting formed. This much amount of energy is getting released. So like that, you have to tell if it is in terms of HCl, that means minus 28602. In terms of water, it is minus 57204. This is how we have to interpret the data when the moles in the stoichiometry is not equal to 1. I hope. Let us see. What happens in this reverse reaction? If 2 moles of water and 2 moles of chlorine is forming, reacting, 4 moles of HCl and 1 mole of oxygen will be formed. But if you consider this is the reverse reaction, this will be of the reactant. These are the things in the product. So whatever the, if you do the reverse way, then enthalpy of the reaction will be positive. If the forward reaction is exothermic, backward reaction will be endothermic. So similarly, if it is a reverse reaction, that means 2 moles of water and 2 moles of chlorine is reacting to form 4 moles of HCl and 1 mole of oxygen. If this is the reaction, the minus symbol will become plus. Here it will be minus, here it will be plus. That means endothermic reaction. So if you say in terms of, per mole of how many joules of energy is required, per mole of water is getting reacted is this one. Now everything will be positive here, because here everything is in negative. In the reverse reaction, everything will be the positive. I hope you have learned the finding of heat of reaction or enthalpy of reaction using heat of formation data. Thank you very much. Let us meet with the new lecture.